Now move to the next presentation, that will be Paulo Artacho and Maria Assunção Silva Dias, presented by Paulo Artacho. That is the interaction between urban and forest emission in Manaus, Amazônia, the Brazilian component of Go Amazon.
Okay, the idea of this presentation is complement Scott Martin's presentation, making it clear what the Brazil have designed in terms to complement on the Brazilian side the measurements that will be done using all the facilities from DOE and all the infrastructure that will be brought here around Manaus. So in order to do that, we wrote a relatively large proposal for FAPESP, together with Assunção, together with Luciana Riso from Federal University of São Paulo, Teotônio, Henrique Barbosa, and almost everybody involved in Manaus into the experiment from UEA, University of State of Amazonas. So we designed an experiment based on the following issue. DOE will only measure the plume after Manaus. So if you don't know what's coming before Manaus and what's happening in Manaus, you never get the correct science if you only analyze the post exposure to the pollution. So the idea is to analyze the focus of this FAPESP large proposal is basically to study before, after the Manaus plume in a very coherent way. So basically we both similar instrumentation that DOE is planning to install into the containers, and we're going to install this in the Ato site, in the ZF2 site, in the Embrapa site, upwind of Manaus, and UEA will do similar things for the Manaus city downtown itself. So in a way of us to have a very comprehensive issue. So basically, in terms of background, just complement what Scott talked about. So basically, we will make a study, an integrated study between the aerosol and cloud life cycles. So it's becoming more and more clear that it's absolutely impossible to separate completely, the water vapor fluxes, the aerosol fluxes from the cloud properties. So basically, this component is designed in a sense to integrate biomass burning, pollution from urban pollution, and also natural emission from the vegetation into a coherent framework to try to understand the process that regulates both the aerosol life cycle and also cloud life cycle. And Amazonia has a very peculiar issue that was demonstrated through many, many years of LDA research, that the links between the vegetation and the forest are extremely strong, extremely active, and there are very few other places in the world where the biology of the forest controls the emission of water vapor, emission of primary organic aerosol particles, and trace gas emissions. Everything goes into the atmosphere, and then this is regulated by radiation. Radiation is mostly controlled by cloud cover, and everything in conjunction makes precipitation and deposition of critical species back into the ecosystem. So basically, we will enhance the understanding of this process into Go Amazon, putting important anthropogenic emissions from the Manaus city into the picture and see how this changes the whole understanding of the cycles. And in addition to that, in addition to the chemistry, what the mostly Assunção component will try to do is basically to understand the change in the surface radiation budget, in changes in the latent and heat fluxes, and change, how the thermodynamic properties of the atmosphere is changing both because of natural emission as well as anthropogenic emission from the city of Manaus. In the several time scales, from diurnal to seasonal cycles, we're going to study this kind of fluxes for the around the city of Manaus. And in the Brazilian component, there is a strong emphasis also in the change in the radiation balance from both pollution plume and also the natural emissions and its interaction. So basically, the aerosol have important components in terms of direct radiative forcing, controlling the the visible radiation fluxes, but also through the clouds there is a significant indirect forcing that we start to have a good fit into this experience. And also, the biology of the forest partially controlled the chemistry and the physics of the atmosphere in Amazonia. This was a result of several different LBA projects, and especially with the recently new findings that basically the plants also emit very, very small amounts of potassium, and this potassium can serve as seeds for particles that are extremely active as CCN because they are very soluble, they are on the correct size range, and so on. So basically, we want to continue to understand how this cycle works, and also how large amount of NOx, large amount of ozone produced from the plume of Manaus could interfere into the processing of the biogenics into CCN in Amazonia. And it's important to understand that in the background conditions that even the site in Manacapuru will sample quite frequently, actually will not be under the Manaus pollution plumes all the time, and we are very interested in learning about this contrast. In Amazonia, the number of CCN is as low as any remote tropical marine atmosphere, and basically we will study the relationship between this CCN, cloud processing, and cloud cover relationship in Manaus. So this is just a transparency that basically showing that for virtually 95% of the particles we measure in Amazonia from the ground, basically all the particles have potassium, or even very, very small amount of potassium. So even if they are secondary organic aerosol, they also have some contribution from potassium, and even if this contribution is on the 20 to 30 nanometer size particles, very, very, very small particles, they can have up to 6 to 10% of mass of potassium. And basically, this is the interplay between emissions from the plants, because this potassium can only come from the plants, but we don't know the mechanisms, we don't know how is the effect of these particles, how do they produce secondary organic aerosols, and this process will be studied on this on the Brazilian component of Go Amazon. And also, in addition to the interactions between the forest itself, it's very important that life does not ends in the top of the canopy of the forest. Actually, the atmosphere is part of the life in Amazonia, and also the clouds are interlinked with the process that controls the biology of the forest. But we are very far from understanding the very complex links between life on the biosphere, the atmosphere, clouds, and so on. What we know, for instance, is that if you sample cloud water very high into the Amazonian forest, even 10, 12, 15 kilometers, we always find inside the cloud droplets fluorescence particles, fluorescence biological particles. So this means these particles are in the cloud droplets, they are alive, and they are processing nitrate, sulfate, and organics in these cloud droplets, changing the surfactants in this cloud droplet. That changes a lot of the cloud properties. So which are the mechanisms for these biological particles goes up, and if you see the number of bacteria concentration in cloud droplets can be very significant. So this linkage were never studied in Amazonia when we plan to study this kind of things. So this is the time series for one of the sites we're going to use frequently, that was also used in the FAPESP Aeroclima proposal. That's the ZF2 ecological reservation. We'll see a strong seasonality of aerosols, doing, as Scott mentioned, to local changes in the production of secondary organic aerosols, and some long-range transport of biomass burning from Itacoatiara and the eastern part of Amazonia. And we want also to understand better this transport and the effects on the ecosystem. In terms of aerosol composition, Amazonia is very unique in terms of aerosol composition, because wherever you go in the world, you see much more sulfate than we're measuring in Amazonia. So the CCN and the cloud droplets are initiated by very different aerosol composition, and we wanted to understand, and we needed to understand better the effects on cloud formation and development due to this change. This is recent measurements of aerosol chemical speciation monitors measuring aerosol composition in real time. So you see a lot of structure in the organic composition, but also in ammonia, sulfate, and nitrate composition into Amazonia. And the idea is to run this kind of composition, detailed composition measured with half an hour time resolution, together with the CCN counted and aerosol size distribution to get as closely as possible of CCN composition and amounts into Amazonia. I skipped some of the transparency. And another important issue that we wanted to study is that in Amazonia, we basically don't see new particle formation observed into the surface on Amazonia. And basically, the obvious question is where 300 or 500 particles per cc that we measure continuously over Amazonia came from. If you don't see new particle formation, where these particles come from? We still don't know, but we will try to find out, especially looking into very different and new proposed mechanisms for new particle formation and activation into cloud droplets that are critically for the Amazonian conditions. Basically, we have very low SO2 concentrations, at least in background conditions, and we will certainly measure high SO2 concentration, high sulfate concentration in the plume of Manaus. How does this partitioning makes in terms of changes in new particle formation mechanisms? We don't know because we never measure it, below the plume with such detail we're gonna do into Go Amazon. What you see in Amazonia that's very, very curious are mechanisms like this. In the middle of the night, this is basically time, midnight to midnight next day. This is particle size, and the color is particle count. So basically you see, for instance, 3 o'clock in the morning, a burst of 25 nanometers particles that you have absolutely no idea of the mechanism that could produce such kind of particles, and they happens basically in 70% of the days we sample in the last 4 years into the ZF2 ecological reservation. So basically this is just to show our lack of knowledge on particle properties and particle mechanisms is still very large for Amazonia. And how does this translate into rain rate is another important issue, especially for Chuva. This is a paper recently published by Ilan Coren that for Amazonia shows that the rain rate directly measuring in millimeters per hour versus AOD have a significant correlation. So why this correlation happens in Amazonia and other sites? In some of the sites we see suppression of rain. In Amazonia we are seeing enhancement of rain. Let's analyze the seasonality of this enhancement and mostly which kind of mechanisms are responsible for this enhancement. So Ben Rosenfeld have done some preliminary analysis for the Manaus cloud droplet size. And basically, what he observed is this. This is the Manaus site. This is more or less downwind of Manaus. This is upwind of Manaus. So basically, what he observed is that when he analyzed cloud droplet size for the Manaus, directly influenced the plume of Manaus versus areas of background upwind of Manaus, and also down here with the small contribution from the Manaus plume, we see a very different vertical profile of cloud droplet size that must have an idea, consequences for the precipitation rate of the region that we still don't know completely. So basically, as Scott mentioned, before the plume of, this is the DOE site in Manacapuru, So we will install a container and detailed measurements here in Iranduba. It's exactly opposite Manaus on the Negro River. So it's the place where you should see most of the plumes of Manaus going out. And then we have several upwind sites of Manaus, Embrapa, ZF2, and also the site of 320 meters Ato Tower that is being built. This is an idea of the Iranduba site. So basically the idea is all the plume from Manaus coming to the site directly, just with the Negro River in between. And the idea is to have the fresh composition of trace gases and aerosol from here, and then analyze how it evolves as it happens to Manacapuru. So basically, the proposal put a lot of objectives that I will not go into detail here, but involved on the aerosol life cycle, on the cloud life cycle, and also the interactions between cloud, aerosol, and precipitation, using several different tools in terms of methodology. And one of the sites will be the Ato Tower. Right now, the 320 meters tall tower are starting to begin the construction. It will take about 1 year to finish, but we have 4 85 meters tall towers that we are measuring them. We are analyzing aerosol and trace gases. Is a very, very pristine region upwind from Manaus. This is the picture of the 85 meters tall tower a few months ago, actually, and we are doing continuous measurement there, and this is the site where we will measure it during Go Amazon for the 2014 and 2015. The other site is the Amazing site that Scott have coordinated. Is TT34 tower that is much closer to Manaus. To reach the Ato Tower, it's a long journey. It's almost 10 to 12 hours to reach the site, but in the ZF2 you can reach the site in about 1 or 2 hours. And the instrumentation we are installed on this ZF2 and Embrapa site is on purpose very similar to the instrumentation that DOE will install in the Manacapuru site. For instance, cloud imager will have cloud cover measurements continuously in Manacapuru, and we also have an identical instrument in ZF2 or Embrapa sites. We have a Doppler LiDAR at Embrapa. They will have a LiDAR also in Manacapuru. So the idea is to compare with as much as possible, with lots of different instrumentation that, of course, also complementing the Chuva sites. These are all Chuva instruments, and whatever Chuva does not have the equivalent instrumentation, we are getting it from this new proposal. And also, the study Gilberto Fish is also part of the proposal, and the idea is to study how the planetary boundary layer grows mechanisms. And this is a slide from the LiDAR that Henrique Barbosa operates at the Embrapa site, showing this very, very nice early morning growing of the planetary boundary layer. And we wanted to study the dynamics of the boundary layer as detailed as possible. So this is some of the issues that you know very well from the Chuva campaign. Some of them will be, at least for 2014, in the Go Amazon site. And also, IAG is already have a product, operational product with 2 kilometers resolution. It's run by Edmilson and Assunção here at IAG, that will run continuously on very, very high resolution around the city of Manaus and how the plumes evolve. And this model will have a full aerosol chemistry to understand the process that will go on. And then this will make the link for Luiz Augusto Machado presentation on the Acredicon, because the aircraft experiments will be absolutely critical to achieve all the objectives of Go Amazon. Thank you for the attention.
Well, thank you very much, Paulo. It's a very exciting field campaign and scientific objective, so it's really an opportunity for the next year. We have a lot of science to do. So, questions?
I don't know how they will do the lightning protection on the tower, and I'm sure I'll not be in the top of the tower to test the efficiency of the system. But of course, lighting is critically important, but I have no idea how they will do that, and this will be difficult. Oh, yeah. Oh, of course. This will be extremely important for the experiment, for sure. You know? Yeah. Actually, yeah, we have 4 mass spectrometer all the time running during Go Amazon, you know, 1 downtown, 2 before the plume, and 1 after the plume. And 2 of this ACSM will be with CCN counters in parallel to them, you know, 1 in the mouse, the chemistry from Go Amazon, and the other our container. So to measure the CCN activity related to size and composition before the plume and after the plume. Yeah, during campaigns, what also will be done is to separate a very narrow aerosol size, fixed size, and look into the activity for that narrow size. So you do that testing the aerosol first over a DMA, you know, you select 100 nanometers particle and measure the CCN activity for it.
We are in Manaus, so exactly probably things that are reached there are produced of 7 kilometers from Manaus.
Yeah.
So there's something very close to Manaus, right?
Yeah.
How about the regions?
So the idea is, the Iranduba site is basically 5 kilometers from Manaus. So very fresh plume there. The Iranduba, just in the other side of the river. Then there is Manacapuru. It's about 60 kilometers. You know, so a kind of aged aerosol. Of course, this aging process continues. It's continuous. And then we will have the airplane to extend this because of logistical constraints. You know, it's very difficult to go, let's say, 200, 300 or 500 kilometers downwind of Manaus. But that is the idea of the aircraft campaign. They are essential in this sense. And I just wanted to complement what Scott mentioned, you know, FAPESP and DOE have signed, you know, an agreement. So there will be joint proposals between American groups and also FAPESP. And the call for proposal is due in maximum of 10 days. So in 10 days, probably FAPESP will have on this site a call for proposal, DOE the same, you know. So the idea and the proposals can be anything related, of course, to the science of Go Amazon. And it will be very important for us to have as much proposal as possible, and also proposals with the FAPEAN. So the third agency will be FAPEAN. FAPEAN and DOE also have an agreement. So basically, researchers from the Amazonian state will also have their funding from FAPEAN. So basically, I think this is an ideal funding situation, but it's always important that FAPESP will be very happy to analyze any proposal outside of this framework for collaboration, you know, because if you have a good idea and a good proposal, FAPESP will also be happy to fund. So the idea is to make the scientific community, you know, aware of this opportunity, and as Scott mentioned, all the data will be freely available as soon as possible, you know. But of course, joint measurements, you know, before, after the Manaus plume, and also measurement done by large team of scientists always are much more productive. So the idea is to enhance collaboration between American and Brazilian scientists, and also to put it together, working more closely with the Brazilian community. For instance, high resolution modeling around Manaus will be very important for the aerosol studies, you know, so the joint work between these communities will be very important.
Yeah, when you say high resolution, and for the case of studs, it'd be very nice you can have it higher than 2 kilometers. And
yes,
it's
always
something that should discuss with CPTech if you'll be able to run something like meters, 100 meters. So.
Yeah, I know, I think, Scott, that the PNEL are also planning to run in between 500 meters to 1 kilometer resolution around Manaus. But probably not with complete chemistry, you know, so we have to do some compromises, you know. But things are progressing very much, you know, fast on this area, you know. But it's, probably will have better than 2 kilometers. But 2 kilometers is already running right now. It's working very nice. We'll validate all this with the LiDAR measurements of boundary layer, you know, and all the things.
Good. Okay, thank you very much, Paul.